Hey guys, today's lesson is going to be on the unit circle. At the end of the lesson, you should be able to use your knowledge of two special right triangles. That's the 45-45-90 triangle and the 30-60-90 triangle to find ordered pairs for angles on a unit circle. All right, so to begin, we're going to first go over the 45-45-90 degree triangle. Because both angles measure 45 degrees, this is an isosceles triangle. And in an isosceles triangle, the legs of the triangle measure exactly the same thing. So let's say that the hypotenuse of the triangle measures 1. We could then use the Pythagorean theorem to find the value of x. The Pythagorean theorem says that if you take a leg squared and add it to the other leg squared, it's going to be equal to the hypotenuse squared. So substituting in a, b, and c, we have that x squared plus x squared equals 1 squared. Simplifying this equation, we get that 2x squared is equal to 1. Solving for x, we get that x squared is equal to 1/2. And to figure out just the value of x, we would then take the square root of both sides, and we would get that x is equal to the square root of 1/2. However, we cannot leave it there. So what we do is rationalize the denominator. So in rationalizing the denominator, it means that we want no radicals to be in the denominator. So x is equal to the square root of 1 over the square root of 2. So all I did was, instead of leaving it as one big square root symbol, I took the square root of both the numerator and the denominator. Well, the square root of 1 is 1, and then the square root of 2 is 2. So what happens here is now this is where the issue lies. We have a radical in the denominator, and then we have to do that process of rationalizing the denominator, aka taking the radical out of the denominator. The way to do that is to multiply both the numerator and denominator by the denominator. So that means we're going to multiply 1 and radical 2 both by radical 2. Well, 1 times radical 2 will give you radical 2, and radical 2 times radical 2 will give you radical 4. So that was just the rules of multiplying fractions. Top times top, bottom times bottom. And simplifying this expression here, we should know now that radical 4, or the square root of 4, is equal to 2. So we could say our final expression would be radical 2 over 2. And that will give us x. Now let's take a look at the 30-60-90 degree right triangle. This is the one that's a little tricky, and it's tricky because of the rules for finding the length of the shorter, the longer leg, and the hypotenuse. So let's say in this particular 30-60-90 triangle, we have that the hypotenuse equals 1. So notice that there is like this reoccurring 1 as a hypotenuse, and it's going to be useful later on in the video. So the hypotenuse of a 30-60-90 degree triangle is twice the length of the shorter leg. The shorter leg is always going to be the side that is opposite the 30-degree angle. So if this is the 30-degree angle, the side that's opposite is going to be this side here. Okay? So if the hypotenuse is 1, then we could set that equal to 2 times x. So what we're assuming is that we're using x to be the measurement of this side of the triangle. So in solving for x, we get that x is 1/2. So the shorter leg is simply 1/2. Now, since we have that the shorter side is equal to 1/2, we can then find the length of the longer side by using the Pythagorean theorem. So the Pythagorean theorem, again, a squared plus b squared equals c squared. We're just going to substitute in what we know. We know that one of the legs measures 1/2, and we know that the hypotenuse measures 1. Simplifying this particular equation, 1/2 squared is equal to 1/2 times 1/2, which will give us 1/4. And then 1 squared is equal to 1. And solving for b, we would subtract 1/4 from both sides, and we would get that b squared is equal to 3/4. Well, if b squared is equal to 3/4, then that means that b would be equal to the square root of 3 over the square root of 4. The square root of 4 is equal to 2. So our expression at the end for b will be the square root of 3 over 2. So the longer side of this triangle will be equal to the square root of 3, or radical 3, over 2. So now that I have that information in my background, I can then apply that to the unit circle. So the unit circle simply is a circle whose radius measures 1, hence unit. So unit meaning 1. So in this unit circle, what I've drawn in is the 30-degree angle, the radius, which will go from the center of the circle to the point of any point on the circle, would measure 1. And I filled in the information that I have for the 30-60-degree triangle. I know that in a 30-degree, 60-degree right triangle, the shorter side is the side that is opposite the 30-degree angle. So here would be my angle, which means that this side here would measure 1/2. And this would be like my 60-degree angle, or the longer side, and that would measure radical 3 over 2. So if I wanted the coordinates or the ordered pair that goes along with the 30-degree angle, I would have the longer side here, which would be radical 3 over 2, comma, the shorter side, which is 1/2. How I know it will be radical 3 over 2, comma, 1/2 is because an ordered pair goes xy, and here would be the length of the leg from 0 to whatever the x value would be here. So that would be x, and then the same thing for this side measurement here as well. This would be my y value, this would be my x value. So for the 45-degree angle, I did pretty much the same thing. I used the information from the previous exercise with the 45-45 90-degree triangle, and I just plugged in the side lengths that I've got. And because it's an isosceles triangle, I know that this side measurement and this side measurement will measure exactly the same. So the ordered pair that goes along with the 45-degree angle would be radical 2 over 2, comma, radical 2 over 2. What I want you to try and do is see if you could figure out the ordered pair that will go with the 60-degree angle. So now let's say we're asked to find the ordered pair for an angle that is not the 30, the 45, or the 60-degree angle. How can we find that angle? Well, to find the ordered pairs for certain angles in a unit circle is actually fairly easy. It's fairly easy because if we go back to our geometry work, we learned 2 types of transformations, which were reflection and rotation. And so many of the angles in the unit circle are reflections of one another, or the points are rotations of each other about the origin. So let's look at the 210-degree angle. The 210-degree angle, if you look at the image on your paper, is actually a reflection of the 30-degree angle. So if you look at the 30-degree angle, it looks like it shoots straight across the origin and then boom, lies on the 210-degree angle. So if that's the case, I can use my knowledge of reflection and also my knowledge of 180-degree rotations to figure out the ordered pair for the 200-degree angle without having to do any other trig work. The rule is you take the original point and then you negate both the x and the y, which means they just turn into their opposites. They don't switch places, they turn into their opposites. So the ordered pair for the 30-degree angle was radical 3 over 2, comma 1/2. So the ordered pair for the 210-degree angle would be negative radical 3 over 2, comma negative 1/2. Well, that concludes today's session. Hopefully it helped and you will be able to find the rest of the angle measurement in exercise number 4. Always email me.